Central angles are always equal to the measure of their arc. So, if we are trying to find the measure of the minor arc and the major arc, the minor arc is always the smaller arc. And I'll show you what an arc is. Let's call this angle 30 degrees. So, the minor arc is the one that the central angle includes in this instance. Okay, so here's the minor arc. So if the central angle is 30 degrees, easy, the minor arc is 30 degrees. And that makes the major arc 360 minus 30 degrees. So the major arc is always the bigger arc, and I'm going to highlight that in pink. Here's the major arc, and that's going to be 330 degrees. Sorry, I was never good at tracing. I think I got a C in art. Always struggled with art. Anyway, the major arc is 330 degrees because that's 360 minus 30. Inscribed angles are always half the measure of their arc. So if this inscribed angle is 20 degrees, this angle here, then the minor arc is going to be 20 times 2, which is 40. So it's going to be 40 degrees. And the major arc is going to be 360 minus 40, which is 320. So the minor arc is 40 degrees. And the major arc is going to be 320 degrees. So now we're given the measure of the radius, and we're supposed to find the length of the minor arc. And we know that the minor arc is 90 degrees. So this gets a little bit more difficult. We have to keep in mind, well, we can do it two ways. Let's do it the radians. Let's convert 90 degrees to radians. So 90 over 360 is equal to 2 pi r, which is the entire, that'll give you the entire circumference of the circle over x. And we know that our r is 4, so we've got 4, our radius is 2, so 2 times 2 is 4. We've got 4 pi in our denominator over x is equal to 90 over 360. And let's get rid of these zeros, and we can reduce the 9 over 360 to be 1 over 4. So let's just make that 1 and that 4. Sorry if it's getting a little messy. 4 pi times 1 is 4 pi is equal to 4x, and we find out that x is equal to pi. Okay, so that's the distance of the circle. Of the minor arc is 3.14. Whatever, because it's irrational. Pi is irrational, it keeps going on forever, but that long in meters is pi meters. In other words, I should label it pi meters long. Let's try one more, but the numbers are a little bit more difficult to work with. So we are trying to find the length of the minor arc. We're trying to find the length of this. So what's that distance? So now we've got, get my black pen here. So now we've got, let's go ahead and convert it to radians. So 2 pi r gives us our circumference, and we're just setting up a proportion. That's what radians are, a proportion of circumference to degrees. So 2 pi r, and our radius is 9, and we're going to be looking for that distance is equal to 360. Remember, part over whole, and 45s are part. And if this angle is 45, it's a central angle, then that arc is 45 degrees. So now we're just trying to find what it is in radians, essentially. So, not essentially, exactly. So now we're just going to go 18 pi is our denominator. X is equal to 45 over 360 reduces down to 1 over 8. So 8x is equal to 18 pi. And so now we've got 18 pi over 8. And then we want to reduce it to 9. Don't use decimals, keep it as fractions, because with decimals you lose values. So 9 pi over 4. So this is the simplest form, and that's the answer.